Okay, great. For our next presentation, we have Steve Mathezer from Ion United, and he's going to walk us through Security Enterprise Active Directory. Thank you.
Can you guys hear me? Sounds like it. All right, I don't know if I can follow up Chet's talk, but I'll do my best here. I'm going to go right into this a little bit and catch you up as we go along. So some of you might remember I did a talk last year which was basically all the things you need to do in your environment that you're not doing and that don't cost you any money. That's kind of my summary of what I talked about last year. So this is step 2. So still trying not to spend too much of your money. How can you mitigate the risk to your biggest attack surface, which is Active Directory, and where most of the attackers have their focus, where most of your stuff is, or the access to your stuff. So that's what I'm going to be talking to you about today. I've done, for the obligatory intro, I don't have an intro slide. I've done lots of stuff. I was a software developer. I led a security team. I've done a lot of pen testing. I teach for SANS. And I'm starting to focus a little bit more on the blue team, or at least purple teaming. And so this has kind of come from a lot of those engagements that I've done in those areas. Just quick review of what I talked about last year. So the first thing is knowing what the hell you're doing. What are you trying to protect? What does your business care about? All of those things. Turn stuff on, and more than turn stuff on. Don't just turn stuff on and plug it in. You know, actually configure it. Use the features that you're paying all that money for. Egress filtering is always a big one. Multi-factor. I was talking to a friend of mine who deals with a lot of incident response and threat intel, and he says the one thing that is actually somewhat effective today for whether we're talking enterprise or the average user is multi-factor authentication. I mean, yeah, phishing. There's all kinds of ways around everything I'm going to talk about, but it's probably the one thing that is somewhat effective across the board. You know, control your management access, passwords. I mean, anyone who does any sort of red teaming can tell you about those. Your administrative access, your monitoring, and patching. We still see people with challenges on that front. So as far as what I'm going to talk about today, one thing I've noticed over the last few years is we have Windows teams that are really good at doing Windowsy stuff. But generally speaking, they're not getting a lot of security training. And we have security teams that most often come from a networking background. They don't know a whole lot about Windows or Active Directory. Who are the ones that are actually tasked with managing and securing Windows, though? Most companies I've seen, that's the Windows team. The security team kind of sits over here and lobs grenades every now and then. But it's really your Windows team that's responsible for your enterprise Active Directory, which is essentially the keys to the kingdom, right? And as a side note, that same Windows team is the one moving everything you've got to the cloud. But that's a different topic. We won't talk about that too much today. So we end up with a bit of the push me, pull you here. As I look at the slide, I should have found that image. Anyways, so we've got security going one way, Windows going the other way, because the Windows team, it's their job. They're all about operations. It's uptime. It's making applications available, keeping the business going. Security team has a different perspective and different motivation, but like I said, they don't have that deep knowledge of the Windows environment. So that's really what I'm going to talk to you about today. I haven't tied this in too much to the MITRE attack matrix, but really what this is you know, we do a lot. Everything we do from a defensive side is based on patterns, right? This started with antivirus. It's all about catching the malware. The MITRE attack matrix is more about figuring out what tactics, tools, techniques the attackers are using and building our defenses around those. So loosely speaking, that's how I kind of came up with my laundry list for today. It's not about specific attacks, although I mentioned a bunch of them. It's about how an attacker is going to get into your environment and move around your environment. So I recommend definitely taking a look at the attack matrix if you haven't already, and starting to change that mindset. So it's not about, Mimikatz. It's about how someone's going to steal credentials and reuse credentials, and how do I detect that, not Mimikatz, and prevent it too. So the other caveat to this is you're not going to do this all at once. It's just not going to happen. It's a journey. It's cliche, but there's a lot of work here. I'm going to give you a laundry list of things that you can and probably should do. I would say that's probably, for the average organization, it'll take years, at least, to get through this. But you got to stop somewhere. Data exfiltration is just as an example. Companies I've worked for, it's like, well, people can burn stuff to DVDs. They can print it out. They can plug in USB. They can go to Dropbox. They can use Office 365. The list goes on and on and on. So, well, why bother? I can't stop data exfil. I'm not going to try, right? That's not going to get anybody anywhere. So don't take that approach. This stuff is hard. There can be business impact. You have to sell the business on it. That's probably the most important thing, is selling the powers that be that this is worth doing. But again, everything hinges on Active Directory. You can have all the firewalls in the world. It doesn't matter. Someone's going to get phished. Someone's going to be on the inside of your network, and they're going to be able to do whatever they want because they're going to own your Active Directory. So let's start, if you come out with nothing else, come out with a roadmap, right? Here's where we want to be, so that, when inevitably we decide to replace Windows 2003 sometime in the next decade, at least you have a direction where you want to go with whatever it is you're implementing next, right? Hopefully that's not Windows 2028 or something like that. But, come out with a roadmap, with an idea that maybe you can't change things today. Maybe you've got that thing that's still running on Windows NT, but someday it's going to die. And someday, you're going to be forced into an upgrade because your business is changing, your data center is moving, your whatever's happening. So be ready. Know what you want to do when those things happen. Get yourself tacked on to the Windows 10 project or the Windows 2016 project or whatever, and start to influence, at least moving forward. And over time, hopefully, you can make a difference. And I said that was the last caveat. Last caveat is there is absolutely nothing original in this presentation. It is all amalgamated, borrowed, stolen, if you will, from a number of sources. In particular, if you haven't had a chance to check out Sean Metcalf's presentations, I strongly suggest you do. His site, adsecurity.org, was pretty much a one-stop shop for a lot of what went into this presentation. And I've got a whole bunch of links in the slides at the end to everything that I stole. So there are, just coming back to the attack matrix, in this presentation anyways, I've come up with 7 ways that acme.com is going to lose. Just general classes of attacks that acme.com is going to fall victim to, and what we can do about it. Number 1, as I said, we could talk about passwords till the cows come home. Passwords are a problem. We need to have them. We haven't solved that part of the problem yet, although we're getting closer, I suppose. I can tell you from my experience, 90 to 95% of passwords start with an uppercase letter, followed by lowercase letters, followed by numbers, ending in a special character. 1 to 2% of users have season and year as their password. Password spraying, if multi-factor is not in place, it's the easiest way to get into any environment. And we have service accounts that are sitting around there with passwords that don't change. Hashes that we can potentially get at, whether that's in memory, on the wire, what have you. And of course, we have the good old human password synchronization tools. As Michael's presentation illustrated very, very well yesterday, right? Humans are really good at keeping their passwords synchronized. So what can we do about that? First off, 15+ character passwords. So you could do this in 2008, certainly in 2012. There is native support now for passwords longer than 14 characters, because if you go into the regular group policy editor, you're limited to 14 characters. There is a thing called a password setting object. I've got a link to that allows you to set passwords however you want in your Active Directory. 15 plus is just a nice number because A, it takes longer to crack, and B, because you can't store LAN manager hashes for that. Managed service accounts, again, I'll talk about this a bit more later. Windows has made it easier to have the operating system deal with your service accounts, so you don't need to worry about their passwords. You don't need to know their passwords. They get managed for you by the operating system. SAML and single sign-on, double-edged sword always, but the fewer passwords people have, the less likely an adversary is going to be able to steal them. It's as simple as that. And the fewer ones they'll have to write down and stick to keyboards and all of that. Length before everything else. I've said it over and over again when it comes to passwords. Honestly, I don't care about complexity. If you start doing math, a 12-character all lowercase password is hard to crack. Maybe that's on the low end, but it's not trivial anyways. So 15, go higher. Encourage complexity. There's certainly, I would encourage it, but at least for the average user, and admin passwords, we can have a different conversation. But for the average user, encourage them to use complexity, but the more you require it, the more you end up with winter 2017 as your password. So I've got a couple of kids, 8 and 11, or almost 8 and 11 years old now. I've been doing this for a while. So I'd take my kids to whatever, beavers, guides, hockey, whatever activities, and they know I'm probably sitting out in the car because wherever we are is too far for me to go home, and I've got my VPN up and I'm doing a pen test of some sort. So it got to the point where my kids were coming out and saying, "Hey Dad, what was it this time, winter 2017? So that was the best education for my kids about passwords, honestly. I didn't have to work too hard on that. But naturally, I have a few computers at home, and they've had computers for a long time. So we've talked about passwords. I didn't make a big deal out of it. For a long time, my daughter's password was pink. But over time, we've worked on that and improved that a little bit. And it does depend a little bit on how your brain works, but the advice that I give them, and the advice now, my go-to advice for anyone for choosing a password, is just pick 2 things you like, 1 thing you don't. So sticking with the theme of my presentation, we have Rocket, Roadrunner, and Cliff. So if you don't want to type that much, it could be Rocket, Bird, Cliff, but I couldn't decide if a Roadrunner was really a bird or not, so I left that in there. Stick a space in there, stick ampersands, commas, whatever. Complexity is not a big deal. If there's the possibility of complexity, as an attacker, I've got to take that into account, right? But that's easy to remember, it's easy to type, and it's hard to crack or guess, right? Simple as that. And if hopefully, by taking the 2 things you like, 1 thing you don't, it's not coming off your Facebook, at least not all at one time. So my daughter's password for the longest time, we dog sat for some friends. She loves the dog, so it was the name of the dog. She likes to ride her bike, so it was bike. And it started out as her brother's name being the thing she didn't like. We switched that to clean because she doesn't like to clean her room either. Point being, she has no problem remembering her password. She has no problem typing it. She's been doing it since she was about 4 or 5 years old. So if anyone tells you they can't deal with long passwords, that's what I'm leading up to, ask to see their text message history. They can type. They can remember. Long passwords are not a big deal. And don't change them as often. The biggest thing with changing passwords today is breaches. You don't want to be using passwords that have been exposed in a breach, or again, back to Michael's presentation from yesterday, that have been sent in plain text over who knows what networks. But again, the 90-day change policy is what gets us into this winter 2017 cycle. So enough about passwords. Local admin access, another thing that can go wrong. So I still see group policy preferences that contain passwords. Long story short, it was Microsoft's old way of allowing you to manage the local admin passwords on all your devices. The only bad thing about that is the password was in decryptable form on publicly accessible login shares. So that's not good. Just check and don't do that. But local admin passwords are the easiest path anyways, to getting full control of your environment. There's still lots of organizations out there, they have the same local admin password across all devices, everybody knows what they are, or not. But if you get one, if you get a hash, you're local admin on everything, which then leads to more administrative access, domain admin, and so on. We have admins adding admins. Saw this a lot. I have a server, it's an application server, so IT doesn't really know what goes on that server, so they need application stewards and business analysts and project managers for some reason to log into that server, so therefore they need to be admins, of course, and manage that application. And what happens? Well, I'm going on vacation, or I'm not going to be here tomorrow, or I'm sick, so I'm just going to go into that local administrators group. I can Google that part and add my project manager or my other BA, and soon it's like Sesame Street, right? Everyone adds 2 friends, and they add 2 friends, and they add 2 more, and 2 more, and then we have a huge mess. And the last thing is, there are lots of relatively trivial ways to get privilege escalation. I mean, just check out your monthly patch releases, but also there's lots of common misconfigurations that lead to privilege escalation, of course, as well. So what do we do about some of that? Easy one is LAPS, Local Administrator Password Solution. Long story short, Windows will manage the local admin passwords across all your devices. Keep them random, change them as often as you like. You as an administrator can pull them out of Active Directory if you need to. You need to be domain admin to do that, so you've got other problems if people are stealing your local admin passwords out of your Active Directory. So turn it on. This is a no-brainer. It has 0 business impact. It's very easy to implement. It supports Windows 2003. So just configure LAPS on servers and workstations, because someone's going to get, people log into both, I guess is the point. I've seen companies where they're like, our servers are the most valuable, we better do it there. Or, well, no one logs into servers, we're going to do it on workstations. Just do it across the board. And allow it to change passwords as often as you want. I know people that change them more than once a day. It doesn't matter. As long as they're set and you have access to them, you're good. Privileged access over the network. I don't know how this is going to work in presentation mode. Yeah, I can't zoom in on that. Oh, now I can. No, just on my screen. Sorry. Probably going to end my presentation now fixing that. There we go. All right, so user rights assignment. There are user rights for things like deny access over the network, right? Deny login via remote desktop protocol. It took me, the first time I tried to actually do this, I couldn't figure out what the heck you were supposed to do here. Turns out you actually need to type the string local account and member of administrators group in there, and then you can prevent people who have local accounts that are members of the administrators group from logging into the, using that right. So, or you can enforce that right for that account, which is, in this case, deny login over the network. So you can't connect with SMB, you can't connect with WMI with a local account. You should hopefully have some sort of out-of-band management solution, whether that's VMware or ILO or DRAC or whatever, and hopefully you're dealing with authentication and validation on that side as well. You don't need a local account for over the network. If you're in front of the machine, fine, log in on the console, but you don't need it over the network. But yeah, you can't select that. You can't browse and select that, just type it in. And there's another one for guest, and there's another one for, I think, just local account, but not member of the administrator group, if you want to do that. Local admin controls. So protected users, again, use protected users. So my brain is full of all of the different controls, so I guarantee you today I am going to mix some of them up. But protected users have a number of characteristics enforced by the domain. You can prevent them, you can't prevent them, I mean you can, from logging in remotely, but when they log in remotely, their passwords are not cached, or their tokens are not cached. Basically, if you RDP into one system, and then try to RDP or map a drive in particular from there to another system, your credentials are not passed through if you're a member of the protected users group. So so for jump boxes, for example, you are not carrying your credentials forward for the bad guys to take. Local admin, there's the Sesame Street thing, right? Like there's no one solution to that. Policy is one part of it. Auditing that on a regular basis is another one, right? It's not hard to query Active Directory or query every system. Bloodhound does a great job of it in your environment to see who's a member of local admins. So do that. Do that regularly. Do it daily, and knock people off. Or make the local administrators group a restricted group, which essentially means now you get to use a group policy preference for good instead of evil. You can create a group policy preference that enforces that only these users are members of the local administrators group, such as your workstation admins. That's the only thing that can be in that local admins group, and that local admins group cannot be changed even by those people. You have to be able to change that group policy preference. Run the tools. See what, again, back to the audit. Get GPP password. I mean, Google these things. It'll tell you what GPP passwords are out there for all to see. Even if you're not using that password as your local admin today, because Microsoft's essentially broken that functionality, that password may still be valid or give me clues as to what I can do to get admin access. Get system and variations. That's the PowerSploit command to basically try all the different ways of privilege escalation on a box. Improperly quoted service paths, service executables running from directories where you have write or anybody has write privileges. There's a number of different ways to get system. Well, see if you can. Especially in Calgary with all that wonderful oil and gas-based software. There's some software out there that doesn't do things very well, that doesn't install itself very well. We'll put it that way. Invoke all checks, I can't remember. I think maybe that one's the PowerSploit one. It's the same idea for seeing how you can escalate privileges. Institutional inertia. I was watching a football game on the weekend, and the commentator said something along the lines of, oh, well, maybe now they'll get some inertia from that play. Like, I don't think you understand what that word means. I mean, there's XP, Windows 7, 2003, 2008, or worse out there in our environment. I blame inertia for most of it. Nobody is willing to actually stand up and do something about it. So do something about it. And there's other out-of-date software, which is usually the reason that you're running Windows 2003, right? So have that conversation. Sorry, that's on the next slide. I'll get to the fixes in a second. Domain functional level. Again, the domain works, right? I can log in, why change it? It's another one of those things that a lot of people aren't aware is there, but potentially, and they certainly aren't aware of the benefits that they get from changing their functional level. And there are many. Stale accounts, again, well, you can't change that password or disable that account because nobody's using it. We'll find out. And older protocols, there's 3 examples. They are roundly abused by malware. But again, something might be using that. I don't know. Well, you know what? What do IT people do better than anything else? They firefight. So, you know what? You break something. So what? We're really good at putting out fires. So find out if those things are used and fix them. So, and this applies to patching as well. Yes, you need to validate, you need to test, and so on and so forth. But it's got to end at some point. Yes, follow change management, do your testing, do your validation. But again, we have virtualization. It's this awesome technology that allows you to say, go back now. Or clone, try it over here. Let's use some of this stuff and stop screwing around trying to make sure that we've reduced our risk to 0 because we never will. Have the business discussions, right? Whatever that is, it's a piece of crap. Is anyone actually using it? Do they care? Has anyone asked them if they have alternatives for conducting business? Can we just get rid of it? Failing that, can we isolate it? So there's good old network segregation. Sometimes is easier than other times. I'm not saying that's an easy one to accomplish in all cases. None of this is really, but it's an option. Remove from the domain. And when I say network segregation, that could be just a single host-based firewall rule to protect the most broken parts. Remove from the domain. Double-edged sword, you're protecting your domain, you're crippling your ability to manage that machine. I mean, so have that. Go through that thought process. Or, you know what, I've got this box because it's the thing that prints the checks. Well, printing the checks is obviously very important, but it is a very clear, finite, distinct process. So whitelist the hell out of it. Again, all I need to be able to do is print. So block whatever network access you can block, because all I'm doing is printing. Whitelist, or blacklist, I guess, or whichever. Use whitelisting so that you're only whitelisting the pieces of the OS that are needed to print. Don't allow anything else. And virtualize, because it gives you more flexibility to, you can apply some stronger security tools at the hypervisor level, you can move things around, you can segregate them, and you're one step closer to being able to get rid of that thing because you can clone it, you can roll things back, and so on. So talking about domain functional level. These are the key security features that were added as you raise your level. 2012 is a major change in my book. I had them all highlighted at one point, and then I decided that looked stupid. But in 2008, you get better auditing. So you've got finer grained control over your auditing. We'll talk about that towards the end, the logging and visibility piece. Fine grained password policies. So that's where you could actually get to your 15-character password, and you could apply it to, you could apply a different policy to your administrators versus your marketing team, what have you. That got better in 2012. Now there's a GUI for it. Read-only domain controllers. That's where managed service accounts first came in, is 2008 functional level. There's even a best practices analyzer to tell you what you're doing wrong. And then 2012 is we got to group managed service accounts. So you could have a managed service account used on multiple systems that was managed by the operating system, so you never needed to worry about the password. There's the UI, like I said, for managing your password policy. But 2012 is where we get the good stuff, like protected users. Like I was saying, don't carry your credentials along with you. You can't authenticate with NTLM. You have to use Kerberos or NTLM v2. I'd have to look that one up again. Restricted admin mode, and I'm probably getting those two mixed up right now. But restricted admin, same idea. Let's just go with that before I get it wrong again. LSA protection is, LSA, the local security authority subsystem service is where all the passwords are. So again, with 2012 functional level, you can turn on LSA protection so that it's harder to actually get at the memory of the LSAS process and get those credentials out. Authentication policies. You can set policies that say this group of users must use Kerberos or can't use DES for their Kerberos tickets and so on. And then in 2016, we get privileged access management, which I'll talk about a little bit later, which has just in time and just enough access. But PAM itself is a whole umbrella of stuff. So let's do some basics. I can't zoom in on this, so I will have to read it to you. But yes, LAN manager is still out there. Go to long passwords, disable it. Really, like, come on. Even XP in 2003 supported NTLM v2. And SMB v1 is only required for XP in 2003, and only for the things that they need to talk to. So there are some opportunities there, for example, to create subdomains, or maybe they're not a member of the domain. If they're not mapping drives, who cares about SMB v1? Turn it off on everything else. Ned Pyle, he's Nerd Pyle on Twitter. He's the owner of SMB at Microsoft. And he says, these are a couple of his Twitter posts. At Microsoft, I cannot emphasize enough how much I want everyone to stop using Samba version 1. That was in April of last year. And then his other tweet, which is more interesting. Day 700 without SMB1 installed. Nothing happened, just like the last 699 days. So again, back to that inertia, just turn it off and put out there might be a fire, honestly, but you've got two choices when there's a fire. Turn it back on because you did it during your change window and you had change management and all of those wonderful things that we're all beholden to, or it broke that one little thing in the corner and you fixed it. So turn it off. And if you need the leverage, any more leverage, just point back to WannaCry, NotPetya, and all of that recent SMB v1 goodness, badness. Other stuff, things to turn off, session enumeration, Windows proxy auto detection, local LAN multicast name resolution, Windows browser protocol, NetBIOS, scripting host, wdigest authentication, untrusted fonts, macros and OLE, I know, but we'll talk about that some more too. They're all things, if you are rolling out Windows 10, for example, at least get them turned off in your Windows 10 builds. Again, moving forward. These ones, some of these are getting tougher or to implement universally, although Microsoft is slowly building them into Windows 10 with every release. But device guard, exploit guard, credential guard. So device guard is basically controlling what code can run in kernel mode, what device drivers you can load, and so on. So it really restricts what privileged code you can get to execute. It also adds PowerShell constrained language mode, which basically says you can only use these types in PowerShell. And I'll talk about that, I think, on another slide. Exploit guard. So just this week, there were some posts about attack surface reduction. I've got that on another slide. You can actually, if you enable exploit guard, you can say things like, don't let PowerShell code that looks obfuscated run. Again, back to attack techniques. It's not about detecting the PowerShell empire. It's about don't allow obfuscated code, or don't allow Office to inject a DLL, an Office executable. I mean, simple things. And credential guard is the piece that protects LSAS. So these are all things to turn on. App blocker, application whitelisting. Do it to the degree that you can. Again, these things, this is, as I said, a process. It's multiple years. It's work. It doesn't cost you anything except work, blood, sweat, and tears. But you got to start doing it. So yeah, there you go. There's the attack surface reduction. This was like this week. These are some of the exploit guard ASR rules. You can block executable content from email client and webmail. So if the OS figures out that's an email client, then it can't run an executable. Office applications can't spawn processes, or can't create executable content, or can't inject code. Scripts can't download executables. Obfuscated scripts can't call a Windows 32 API from an Office macro. Like, these are all huge. Like, that's the laundry list of the most common attack vectors. So stay on top of these things. You have to be able to take advantage as they come. Again, you've got the Windows people over here figuring out how they're going to migrate stuff to the cloud. You've got the security people over here dealing with everything else. No one's dealing with the actual security in the area where it can make the biggest difference. Another way you can go wrong, subdomains. They are not a security boundary. Domain admin in a subdomain equals domain admin in the forest. It's just as simple as that. As Microsoft says, the forest is a security boundary for the information that is contained in that instance of Active Directory. So I don't really have much to say about that, except that everything is in your Active Directory, and it is replicated to everything, at least the key parts of AD are replicated to every domain in the forest. It is not a security boundary. Admin privs at the domain level. I did an assessment of a 400 person company that had 85 domain admins. That's probably a little bit on the extreme side. Their manager of physical facilities was a domain admin. I think his password was Gunner. Regular accounts as admins, whether that's added to the local admins group or to the workstations admin group or whatever, regular accounts, not doing that separation of duties. Service principal names, so service accounts that are registered with the domain, but of course, anything that needs a service account, that service account has to be domain admin. Isn't that the way it works? Right? If you're creating a service account, your virtual admins, right? If I have access to your VMware environment, or sometimes fun, your VMware backups, I am essentially a domain admin if your domain controllers are virtual, right? Those people are just as important as your domain admins. Delegated permissions and ACLs. It's awesome when the help desk can do password resets or join computers to the domain. But it is also amazing how far those permissions spread within the domain. There are ACLs on everything, and they get changed. And people with regular accounts, I don't know how, but they end up with control over OUs that contain accounts that then have privileges, or systems that have privileges, and so on. You have to, and this is, I'll show you on the next slide. This is some of the new The newer attack tools are really starting to take advantage of delegated permissions and Active Directory ACLs, even to maintain persistence. So I'm a regular user in the domain, and I update an ACL that says, I have update access to your domain admins group, for a simple example. I don't show up as privileged. Like, you have to go looking to find that I have right access to your domain admins group, and I just need to tweak something every now and then, or reset password access to key accounts, right? You may not be compromised now other than that little ACL, but I can use it to do everything I want. Your directory services recovery manager. You know, when you install a domain controller, it asks you for some password for something you have no idea what it's really going to do with it. That's so that if you completely blow up your domain, you can do kind of an offline recovery of it. Well, you can also use that online, and it's domain admin access. Do you know what that password is? Was it created when your domain was created back in 1997? Was it your company name or password? Because I'm trying to get a domain up and running here. I don't have time to think up a good password. Well, that's domain admin. Same with your out-of-band management, you know, your ILOs, your DRACs, your virtual consoles, all that kind of stuff. And just frankly, users with too much privilege. Again, we are terrible, and I don't have a good solution for this one, but we are terrible at provisioning the appropriate amount of access for people. We always give them too much. So Bloodhound, if you've never seen Bloodhound, download it and run it. And then, you know, go see your shrink and come back to work a little bit later. Bloodhound will draw you a directed line graph of your environment with typically domain admin over here as the goal. And those nodes along the way are relationships between objects in your environment. So this user has an active session here. This user is an administrator there, so therefore you can use that to steal that user's credentials, and then that user is an administrator here and you can steal their credentials. That was Bloodhound's first version. Then they added in stuff like delegated access. So this account has delegated access to this group of which this user is a member, and they're an administrator here and on down the road. And ACLs as well. So I think some of the edges in here are forced password reset. So this user has the ability to reset this user's password, who's an administrator here, who can get in here, who can go in there. I mean, Bloodhound's noisy. Hopefully you can detect it as if you are on the defensive side of this equation, but run it. Run these tools regularly because the attackers are. So why shouldn't you know what they are going to find? And this is one of the easiest ways to audit these kinds of hidden delegations and ACL permissions in your environment. And yes, you get the directed graph, but Bloodhound also creates CSV files of the output. So those are potentials to import into your SIM and your other tools to do a lot more automated remediation for this kind of thing. And as a bonus, by running it yourself, learn to detect Bloodhound activity, right? And then try to be more stealthy, and then learn to detect that. More auditing and validation. Kerberos, another tool. I was talking about service principal names. Services register with Active Directory so that you can request a Kerberos ticket from Active Directory so you can authenticate yourself to that service, more or less. In so doing, that allows you to query the ticket you get from Active Directory is based on that account's password, which can be cracked quickly, depending on your hardware. Not as quickly as NT passwords, like it's many orders of magnitude slower, but they can be cracked. So again, run Kerberos, learn how to detect that, and certainly remove the unnecessary SPNs, or, and make sure, how often do you type in your service account passwords? Hopefully not very often, because you shouldn't be logging in with a service account. Therefore, it follows that service account passwords can be incredibly long because you never have to type them. They're in a password safe somewhere that has multi-factor enabled, hopefully, and doesn't have the human synchronization of passwords going on for access to the password safe. That's another good one. So passwords on service accounts, there's no reason they can't be 20, 25 characters more. You're just copying and pasting them once in a blue moon. Or use a managed service account. I think I must have said this a few times. Virtual admin access to domain controllers. Out-of-band management, DSRM, protected accounts. So again, with Kerberos, when you connect to a web server and then access a backend database, for example, that web server is proxying your access to the database, right? It's impersonating you to talk to the backend database and gain access to stuff. That is required for a lot of applications to work, don't get me wrong. But that doesn't mean it should be a complete free-for-all. That web server shouldn't be able to impersonate you to everything in the environment. This is a relatively complex and involved topic. Check out Sean's SparkCon presentation for many, many slides on that one. I'm not going to go into massive detail, but basically, protected accounts allow you to control how that account can be used for delegation. So your service accounts are basically your service accounts and your min accounts are the prime candidates for being protected accounts. You've probably seen some variation on this slide if you've done any digging into Active Directory. This is Microsoft's Utopia. Worry about the yellow right now. So you probably can't read that, but we've got 3 tiers: Tier 0, Tier 1, Tier 2. Tier 0, think Ring 0 if you know how to say Bell LaPadula, and you know what the Bell LaPadula module is. Think your most privileged stuff. So your domain controllers go at Tier 0. Tier 1 is your servers, Tier 2 is your workstations. So there are 2 things. Can you hear me? There we go. There is your ability to manage and your ability to authenticate. So you should only be able to manage across and down in special cases. That's what this slide is basically saying. You can manage at your level and down if you need to. And you can authenticate up or at your level, but you can't authenticate down. This is one of those roadmap things. Start thinking about Tier 0. Right? Get your domain controllers in a state where you control the access to them and the management of them, and you get that nailed down. We've got some customers working on Tier 1, which is the server level, and that's a challenge. Workstation level is a much bigger challenge after that. So, take it, again, this is roadmap stuff. Along with it come privileged access workstations and enhanced security administrative environment. So short version is a privileged access workstation is what it sounds like. You use that thing only for administration. You don't use it to do day-to-day stuff, and it is secured. So in some organizations, that is actually a laptop that is a member of another domain that has nothing installed on it other than AD administrative tools that you patch out of band, or basically doesn't allow inbound connection. So it goes out to fetch its updates from WSUS or something similar, has no other tools on an isolated network that you may not allow inbound connectivity to that network at all. You may have to walk over there to that workstation and log in, and the only thing that can log in there is certain accounts, and so on and so forth, right? It's an isolated, excuse me, it's an isolated workstation. Microsoft also does support or recommend this concept of making your primary workstation that workstation, and then running your day-to-day PC as a VM inside that workstation. Not the other way around, but because you don't want to have something that's not privileged having access to your virtual memory. But that is a way to do it if you don't want to go to the full extreme of isolating it. But honestly, you really don't need to use domain admin privileges very often. You don't need to log into domain controllers, and you should know every time anybody logs into a domain controller, period, because you shouldn't have to do it very often. So have those workstations, make them physical, and make somebody walk over and log into it. Better yet, make somebody else unlock the account that allows them to log in. There's no reason for it to be unlocked at all, or enabled, I guess is a better term, all the time. Enhanced security administrative environment. So short version is dedicated administrative forest. So put all your admin stuff into a completely separate domain. That looks kind of something like this. The idea being, some people call it a red domain. You have, and in this case there's 2 of them, you have a red domain. All it does is holds the accounts that allow you to manage your domain controller. So that would be, well, period. So you have a one-way trust. And then no matter what happens to your domain, nobody's going to get administrative credentials because there are 0 administrators in your production domain. They're all in this other domain over here that is locked down, and so on and so forth. And then optionally, you can add a second other domain, which is the one that holds all of your privileges and users that manage or that work in your production domain, right? This stuff doesn't happen overnight. I haven't had time to dig into it. 2016 facilitates this a little bit, allowing you to kind of manage it all under one umbrella while still keeping it separate. I'm not sure quite how that goes, but I haven't had time to look into it in depth. But these are all things you need to be working towards, especially the tiering, starting with tier 0. So there's another tool called Privileged Access Management, PAM, in 2016, and it has 2 goals. One is to reestablish control over a compromised Active Directory environment by maintaining a separate bastion environment that is known to be unaffected by malicious attacks. So this is what I'm talking about in 2016. And then isolate the use of privileged accounts to reduce the risk of those credentials being stolen. So PAM is basically creating that red domain, but virtually within 2016, like within your 2016 domain. And it leverages just-in-time and just enough access, which are tools to limit the scope of any administrative access that you have. That's another deep dive that we don't really have time for. So I'm going to come back or move on to endpoints. Endpoints are where it's at, right? That's where all the bad stuff lives. It's what it takes advantage of. It's what it's attacking. PowerShell, we all know about the PowerShell frameworks. Phishing, you end up on an endpoint after you phish someone. Drive-by downloads are still a thing. And attackers generally want to get onto an endpoint and pivot. Macros are a great way to do a lot of this, as is other executable content. So again, I'm not trying to sell you any Utopia here, any silver bullets, but all of these things do contribute to raising the bar for an attacker. So get to PowerShell 5.1, remove 2.0. I don't know if it's this creator's update. 2.0 will soon be gone from Windows 10. You won't have that choice. And PowerShell 6, I think, is coming out very, very soon as well. Constrained language mode, like I said, so limits allowed types. It basically stops PowerShell from talking to the Windows API. And again, yes, you have PowerShell in your environment. You should. It is the most valuable administrative tool that you have. You can't and shouldn't ever turn it off. But you can restrict who can run PowerShell, and you can restrict what you can do with it. And yes, you can bypass that stuff too, but again, we're just trying to raise the bar. AMSI, I didn't know where to put that in here, but I wanted to throw it out there. There is an anti-malware scan interface in Windows 10, I believe, that basically allows antivirus products to hook into the scripting engine and get fed the PowerShell scripts or any PowerShell and other scripts that the operating system is running. There are, I believe, 3 or 4 out of, 50 to 100 antivirus vendors who actually support AMSI. Again, it's not a silver bullet, but beat up your vendor because they should. There's no reason not to support it. Otherwise they don't get to see, they may have other techniques and ways of doing it, but why wouldn't you subscribe to the monster that is Microsoft and get all of the stuff that it's going to feed you, right? Enable transcription module and script block logging for PowerShell. And we'll talk about logging and visibility as the last section here. Run sysmon. There's been lots of talk about sysmon. Whatever it is, it doesn't have to be sysmon, but get endpoint visibility. But first I'm going to talk about network, the network side of endpoints. Restrict the inbound communication to endpoints. Who needs to initiate a connection to your endpoint? Yes, there are exceptions. There's stuff like Skype, although most of that is outbound now. VoIP, those kinds of things. Sometimes there's a requirement for remote desktop. But beyond that, who needs to initiate a connection to an endpoint? Why do you allow it? Or why should you allow it? And certainly, why do endpoints need to talk to each other, ever? This is probably one of the single most effective controls you can put in place to stop a bad guy from wandering around your network, is just don't let endpoints talk to each other. There is no reason. So, because usually, sometimes it's possible to get everything you want off of the endpoint that you landed on as an attacker, but usually you're trying to find another endpoint where there's somebody with privilege or some other piece of information that you can use to elevate your access. So don't let that communication happen. So doing it at the network or firewall level is good because you have centralized control and it's not an endpoint technology that is implementing that control, but you have intra-VLAN issues, which is where private VLANs come in, and it is actually harder to manage because you have to manage it at all of those different intersection points of your various networks. So turn on an endpoint firewall. Again, Chris will probably turn it off, but try to notice that is happening so that you at least make him turn it off so that you have that opportunity to see that he's there, right? So simplest case, use a GPO, apply a Windows firewall that basically says block all inbound connections except from my server network and my sysadmin network and allow RDP. Block everything else. Like, I'm throwing that out there, it's something simple. You can do that with a GPO, push it out to everything. All of a sudden when I land on a workstation, yeah, I can change those rules if I can elevate my privileges on that workstation, but you can detect me making those changes. You can hopefully detect me elevating my privileges without being able to wander around the rest of your network. Right? It is an incredibly effective means of at least slowing down and making attackers visible. So I said I'd come back to macros. Yeah, I know, we use macros. Not as much as you'd think. There are definitely people who use macros. But I can tell you, the average computer user doesn't know, I don't know, I'm just trying to think of something really obvious that the average person who uses a computer doesn't know how to do. But you get where I'm going with that. You really think they know how to use macros? Like, yes, there are teams, accounting being by far the biggest culprits, they need to have macros enabled. Does your HR department need to have macros enabled with all of those Word documents that they're opening? Like there's case in point. If you disable it for anybody, disable macros for HR because they love to open documents. So if you do just that, it's progress, right? Who really needs them though? Yeah, accountants, production accounting, those kinds of things. Turn them off everywhere else. You can use a GPO to target that appropriately. And with Office 2016 now, you are actually able to do that in a targeted fashion for downloaded content only. So again, maybe that Inertia is rearing its head again and you can't make this kind of change globally. But you can for Office 2016, or sorry, you can for content downloaded from the internet. Run macros all you want internally. It's progress. I'd rather you didn't, but that's a step. Do something with all of the different kinds of potentially malicious files. One easy thing to do is change the file association so that if I double click on a .bat file, I get Notepad. Again, target that. Your administrators probably would find that annoying, but all of these file associations, I should not be able to open them. Who uses HTA files, really, especially attached to emails? I'm curious, anyone know of a legitimate use? Yeah, I didn't think so. I use them all the time. But again, don't let people use these types of files. There's lots of ways to turn them off. Like I said, changing the file association is a simple one. App whitelisting, the other bugaboo that Inertia kind of puts a crimp on. What am I doing here? Not too bad. So start slow. Turn application whitelisting in log-only mode and start to build your exception list, your whitelist, right? And then start at a high level of granularity. Like, I'm going to just whitelist C Windows, C program files, x86. I'm also going to check to see if there's any world writable directories in there before I do that. But open it up that wide, or just lock down the user's profile folders. Permit signed executables, or at least don't alert on signed executables. And yes, there's a lot of talk lately about how to bypass that. But again, we're just raising the bar. Empower your SOC or whoever that is, right? Turn on the logging with AppLocker. And if you start to actually block with AppLocker, then just empower your SOC. Oh, I got an alert because something was blocked. I'm going to check that with VirusTotal. If it says, then you probably don't make a change. If it says, yes, that is probably good, which is VirusTotal code for we don't know of anything wrong with that, we've never seen any problems with that file, then your SOC could proactively add it to the whitelist, and maybe by the time the user clicks it again, it works, right? Like, you can make this stuff easier on yourself. And again, start building that corpus of data. Start learning what you need to allow run in your environment. And then, just as an example, Citrix or remote access servers. Those are the best defined servers in terms of what applications can run because you just had to script them all to make them available in that that platform. So why can't you whitelist what they need to do? Because you shouldn't be doing anything else on a Citrix server, and that's also a nice target for attack. So real quick, this is the one piece that you may need some outside tools for, particularly SIM, but visibility. There's been lots of talk about this, so I won't go into it in massive depth, but command lines, ports and sessions, processes, parent-child relationship of processes, the accessing and changing of privileged things. There's one thing I want to point out there. The use of privileged access, PowerShell logging, as I said, new or novel behavior. Now we're getting into machine learning and all those fun buzzwords. But tailor some use cases. If you saw Julian's presentation yesterday, he had, what, 21, 22 of them? A lot of them were really, really good. Most of them were. Check out his presentation if you didn't see it. The big one for me, in terms of the simplicity versus effectiveness, the 80-20 rule here, turn on object auditing for your administrator groups, for local admins and domain admins. And when I say what I mean by object auditing is every time someone queries that object, you can get Windows to generate an alert. Who needs to see who's a member of the administrators group on a daily basis, or the domain admins group? Who's querying those things on a regular basis? There may be some stuff, and you'll have to exclude that from your alerting. But once you figure out what the stuff is that does normally query those things, then you're set, because the first thing an attacker is going to do when they land on your network is figure out who's in the local administrators group and who's in the domain administrators group. And they might use WMI, they might use PowerShell, they might use net local group administrators. So, and yes, you can watch for all those command lines too with sysmon or what have you. But why not just create an event when someone reads the group? Hopefully you get that event before they get enough access, well you should, before they get enough access to disable sysmon, right? That I've seen multiple environments where they're catching adversaries or red teamers within a few minutes based solely on that. Other stuff, LSAS access, lock it down, turn on protection, that's credential guard. Command line length, character set profiling, so long command lines, long DNS names, long URLs, all that stuff. There's a tool called freq.py, F-R-E-Q, .py, does frequency analysis based on a dictionary that you give it. So you feed it what is normal service names, what is normal file names, executable names, whatever. And it will then build a dictionary that allows it to, or a database that allows it to tell you when something doesn't match that. So use that against executables, command lines, scripts, all that stuff. Look for Office or browser as a parent process, changes to privileged groups or GPOs. Anyone querying ACLs, again, we don't go asking Active Directory, what are the ACLs on the domain admins group? Very often. Monitor your privileged access workstations and your administrative domains and the use of your privileges. How about credential manager? So I mentioned SAML earlier. I've had this, I bring this up because I've had this happen multiple times. I land on a box, they've got a good password policy, or I'm kind of stranded for a little bit. I haven't figured out how I'm going to elevate privileges. Then I realize they use Office 365, but they don't use SAML. So the passwords are stored in Credential Manager, which are readable by the user that I am logged in as. So I just dump everything out of Credential Manager. So, but again, who sequentially reads through everything in Credential Manager? You might ask for a credential, but not this one, this one, this one, this one, this one. And then I reuse those passwords, of course. Usually they work for domain admin. I've had that happen. Poor man's UBA. So PowerShell module logging. Just throwing these out there as ideas. So PowerShell will log every module that is run. So run that for 30 days. Log them all, hopefully in a normal environment. Remember what that list is. Every time a module that you have never seen before gets run, that's something to investigate, because PowerShell doesn't normally do DLL injection. So whatever the modules are that the malware is running, they're not normal. It will hit some that are not normally run. Same thing with sysmon. You could baseline the normal executables for your environment. And logon activity, right? Build a running list of where the users log in. Again, you can do that on an ongoing basis. This user has logged into these 10 machines. When they log in somewhere new, generate an alert. It takes some maturity and some ability to respond to these things, but they're hugely valuable. And I want to throw out there, yeah, as Julian said yesterday, don't alert on failed logins, but alert on an unusual number or change in the number of login attempts. Because I'm going to password spray, everybody's going to do that, but it's going to generate more login attempts for Monday morning at 8 o'clock or overnight than is normal. So alert when there's a standard deviation change in the number of attempts, right? So it's poor man's UBA, but those are some of my favorites in terms of effectiveness. Other stuff, clean out your CAs, control your SSL, TLS, SAML as I talked about, patch, and build that mind share. Have a plan. Figure out, build your roadmap. Talk to some of this stuff and get those two teams, get one of them to turn around in the canoe, right? And get going in the same direction, focused on your AD security. So I left you, 0 minutes for questions, but are there any questions? All right, I'll be around if you want to talk further. And these slides, I'm sure, will be available. I've got lots of links for you to look at as well.